The population of the abra, the rare golden cat, can be modeled by the function blah. Does anyone know the reference? It's okay if you know. I won't believe that you live in your mom's basement. No? Okay. It's a Pokemon. Yeah, it is. Yeah. It's the third evolution of the... No, it's the first of the evolution of the abracadabra. Yeah. Is that in there too? See, so it's abra, then abracadabra, then alakazam. Nice. Oh, Pokemon. Yeah, they look like cats. Well, yeah, it does. Maybe it's more of a fox. It's an animal. Where T is the time, I have to edit that all, no, I'm keeping it. Where T is the time in years from 1900. Part A. A lot of stuff going on here, but we can fit all parts on this slide. Find the population in the year 2000. How do we find the population in the year 2000? Plug in 100. So we're really finding P of 100. Now this is going to be a decimal here. I don't say anything about rounding here. So why don't we just go to the nearest whole number? I think that'd be the easiest thing to do here. Now keep in mind, you should put the 0.02 times 100 in parentheses in your calculator. And what do you get rounded to the nearest whole number? 3. Part B, find the population in the year 2001. So basically the exact same thing, except instead of 100, we use 101. Notice that this is an exponential function where the base is greater than 1, which means it's always increasing. So that means this population should be slightly larger. And rounded to the nearest whole number, what do we get here? So part C, subtract these two values and interpret. So this is just like our previous one. Notice the order in which we're going. 3769 minus 3695 is what? 74. So what does that mean? Well, did we find a derivative? So it's not a rate of change because it's not a derivative. In the year, yeah, so during the year 2000, 74 more abras were born. Any of those are fine. Yeah, 74 abras. So in other words, there's 74 new abras by the year 2001. All right, part D. P prime of 100. This is the rate at which the population is growing in the year 2000. So by what we did before, this should be approximately the same thing as 74. So the C and D's answers should be close to one another, relatively speaking. So how do we find P prime of 100? P prime of T, right. So what is the derivative of 500 e to the 0.02 t? So I'm going to do the unsimplified version first. So the 500 sticks around, the e sticks around, and then you multiply it by the derivative of the exponent. So the 500 times 0.02, boop, boop, that's 10. This 10 that people have been talking about. So to find P prime of 100, we'll stick 100 into that. And again, we'll round to one decimal place, to the nearest whole number. What do we got? 74. Now again, this is off. It's not technically the same thing as we were off due to rounding, but hey, we're relatively close. But notice again, that was only a 1 year difference. But if we did more than a 1 year difference, they're not going to be relatively close anymore. And notice the next couple examples are a 10-year difference in the year 2000. Oh, it does say interpret. You're correct. So population is increasing by 74 cats per year. We need Conan O'Brien for this in the year 2000. No one? You know, you got it? Good. E, find the population in the year 2010. What number are we sticking in for T? 110. 4513. And I want you to try F on your own. use parts A and D to approximate the population in the year 2010. So what's the setup? P of 110 is approximately, yeah. So P of 100 is the population in the year 2000. And 10 times P of 100 is because that means that rate of growth is growing over the next 10 years. Is that okay? So whatever the difference in years is, that's this number here. So previously, when we talked about 101 and 100, we could have said P of 101 is approximately, tilde, P of 100 plus 1 times P prime of 100. We just didn't say the 1 because it didn't make a difference, because it was only a 1 year difference, okay? But if you have anything higher than that, then that coefficient is important. So we'll have P of 100 from part A is 3695, plus 10 times P prime of 100 is 74. What is 3695 plus 10 times 74? So notice we're off by 78 abras. So part E is the actual, but anytime you use the derivative, you're doing an approximation. And by what we had earlier, notice here that the derivative is smaller than the actual. Oh, they changed that. Oh, okay. Oh, I erased this. Hold on. How do you draw a sad panda? So anyways, if we were to graph this guy, remember exponentials are always increasing, something like that. Well, here's the real value at 110. Oh, I'm very sorry, at 110. So this is P of 110. So that's part E's answer. Well, if this is 100, again, slight exaggeration with the graph. And we draw the tangent line there. Notice the tangent line is below the actual value. Okay. So we're going to be a little bit off. That's okay. Hooray! That is section 4.6. Oh, I gotta finish this panda correctly. Oh, I erased him again! How do you make a sand panda squared?